Okay, today's algebra lesson is 6.2, solving systems using substitution. So yesterday we did 6.1 and it was over solving systems using graphing. So remember that a system is two or more lines and basically you're finding where they intersect, or two or more equations and you're finding the ordered pair where they intersect. So today I think you can check out all of your notes, and what you'll notice is, guess what? There's no graph paper. So that is because we are not solving systems by graphing today. Instead, we're using something called substitution. And it actually works kind of like what it sounds like. We're substituting something. So let's figure out how to do this. Solving systems of equations can be done in more than one way. We already talked about that. The other way is graphing so far that we've learned. When a system has at least one equation that can be solved quickly for a variable, that's when we would choose to use substitution. That's when it would be the best choice. So let's take a look at these two equations it gives us in problem 1. It says use substitution to find the solution. So step 1 says because y equals 3x, you can substitute that 3x into the other equation. I want it to really make sense to you. So here's what I want you to notice. Y equals something, right? Y equals this 3x. So what I want you to understand is it's telling you what y equals. It's saying y is 3x. So in the other equation, I don't want you to look at y as a y. I want you to look at it as what it tells us y is, which is 3x. So I want you to look at this. Try to envision it in your head. This is actually x plus, not y, but it's what y equals, which is 3x. So x plus 3x equals negative 32. So that's what we're going to write. We're going to write x plus no longer y, but 3x equals negative 32. And what we have done just now is we have substituted what it told us y equals for what y is. So we have substituted 3x in for y. Okay, and let's keep going. We can easily solve this. 1x, that's a hidden invisible 1. 1x plus 3x is 4x. And then what you could do to solve this equation is you would divide both sides by 4. And you would see that negative 32 divided by 4 is negative 8. So now we have our x coordinate. And remember, when you're solving systems, what you're trying to do is you're trying to find an x and a y coordinate. And right now, we have half of our answer. We have our x coordinate, which is negative 8. So without even graphing, without graph paper, we have one half of the answers we need in order to see where these two lines would intersect if we were graphing them, which we're not. So now we can go back, and knowing that negative 8 is x, we can either put negative 8 here for x and see what you think y is, or we can just stick negative 8 in for this x. And honestly, it doesn't matter. You'll get the same answer with either one. So to me, it almost looks like this is a shorter equation. Let's just use this equation. So we're going to go back to y equals 3x. And now that we know x is negative 8, I want you to put negative 8 in here. We're substituting negative 8 in here for x. So y equals 3 times negative 8, which is negative 24. And now we have our y coordinate. It's negative 24. So put it all together, and our entire solution is negative 8, negative 24. And this is an example of why we do not always use graph paper. If I gave you a piece of graph paper, negative 8, negative 24 would be way over here and way down here at negative 8, negative 24. It'd be way off the graph that we usually give you as far as graph paper. So that's why it's important to be able to solve it in a different way than just graphing. Okay. Yeah, we did all that. Let's move on to the next one. So let's look at this next problem. Y equals 2x plus 7 and y equals x minus 1. So in this case, it's more than just one term. Like up here, it was just 3x. Here it's telling us y equals this whole like two terms, 2x plus 7 and x minus 1. But it doesn't matter which one we use, but we're going to borrow one and substitute it into the other equation. So I'm going to go ahead and just borrow 2x plus 7. So it says y equals 2x plus 7. So instead of y, I don't want you to see that as y anymore. I want you to see it as what we're substituting as y. So I want you to rewrite this equation, but instead of y, put 2x plus 7. And then we need to write the rest, which is equals x minus 1. And then we're going to solve it, because I want you to know right now it's impossible to solve an equation if you're missing both y and x. That's why we substituted into the other one, because now look, we only have x and x. So this is solvable. If you have two missing variables, it's not solvable. So we're plugging it in so that we can solve it. So I'm going to choose to minus the 1x from both sides so that I can move it off of here. 2x minus 1x is just 1x. Bring down your plus 7 equals negative 1, minus 7 to both sides. This is why you need to be really good at solving equations in algebra. Negative 1 minus 7 is negative 8, and we now have our x coordinate. So out of our solution, we now have half of our answer. And that's interesting because our answer up here was negative 8 as well. That's a coincidence. Okay, and then now that we have our x, we need to find our y. So we can do one of two things. It doesn't matter. We can plug in negative 8 for this x and solve this equation, or we can plug negative 8 in for this x and solve this equation. And I'm going to choose this one because look, you can almost do that in your head. Negative 8 minus 1, and that is y. So it's basically already almost solved. Negative 8 instead of x is no longer x, it's negative 8 because we just solved it. Negative 8 minus 1 more is negative 9. So y is negative 9. I know some of you skeptics might be like, yeah, but it's negative 9 in this equation, but what would it have been if she plugged it into this equation? Let's see. If I plugged in negative 8 here, it would have been 2 times negative 8 plus 7. 2 times negative 8 plus 7. Guess what? It didn't matter which equation we chose. It's going to be negative 8 comma negative 9 in either equation. So you can substitute it in either one. All right, let's try another one. So sometimes you may not have one that's real obvious. I don't want to substitute for y or x because look, there's a lot of rearranging I'd have to do to get x by itself or to get y by itself. In this other equation, there's not a lot of rearranging. Y is almost already by itself. So I'm going to choose to get y by itself in this equation so that I can see what y is equal to. So to get y by itself, I'm going to add 2x to the other side. So now y equals 2x minus 3. All right, this one was the best choice because with this one, I would have had to subtract something and divide by something, and it's a lot more work. With this one, I just had to add 2x to both sides, and now I can see that y is no longer going to be y. I don't want you guys to look at this other equation and say, oh, well, that's y. It's not. It is now going to be 2x minus 3 because that's what y equals. So I'm going to grab this and I'm going to substitute it in to the other equation's y. All right, so I'm going to rewrite this first equation, but instead of y, I'm going to write what y equals, which is 2x minus 3. So let's go over where we have some space and let's rewrite this equation. 3, not y, 2x minus 3. We're substituting 2x minus 3 in for y. Plus 4x equals 14. Okay, and again, the reason we're doing that, the reason we're substituting something into y is because I can't solve an equation if it has two missing variables. But this one now only has x's, so you can. 3 times 2x, you have to distribute. 3 times 2x is 6x. 3 times negative 3 is negative 9, plus 4x equals 14. Combine your like terms. 6x plus 4x is 10x. Bring down minus 9 equals 14. Add 9 to both sides. 10x equals 14 plus 9. Or sorry, why did I put 14.9? 14 plus 9, which is 23. Divide both sides by 10. This is not going to come out even, but that's okay. We can have decimals. It is okay to have decimals. 2.3. Okay, 2.3 is x. So, and this is another reason that we would not want to graph this one. I don't want an intersecting point going to be not exact number. So our x coordinate is 2.3. 2.3 comma, we don't know what our y coordinate is. But now that we know what our x is, we can take it and plug it in for x, because that's what x equals, in either one of these equations. I can plug it in here, or I can go over and plug it in here, and it does not matter which one. I'm going to use the second equation. Doesn't matter. It just, to me, I can do these two numbers in my head. It seems a little bit easier to solve, and actually I'm not going to do it in my head because it's a decimal. So I'm going to rewrite this equation, but instead of x, I'm going to put 2.3 because that's what we know x is. So let's write this equation. -2 times not x, but 2.3, since that's what we just solved x to be, plus y equals -3. And by the way, you might be thinking, well, can't I just plug it back into this rearranged equation? Yes. Actually, that's better. I should have done that. I should have plugged it in right here. But that's all right, because now I'm already working on this one. So, and it won't matter. See, like I said, it doesn't matter. As long as you're plugging it in for the correct variable, you're good. -2 times 2.3 is -4.6 plus y equals -3. I'm going to add 4.6 to both sides. Y equals whatever -3 plus 4.6 is. 1.6. So our y coordinate is 1.6. Okay, let's try another one. So the whole goal is I'm looking to get either x or y by itself. This looks like a lot of work for either x or y. This one, though, I've almost got x completely by itself. All I would need to do would be to subtract 3y to the other side. So I'm going to do this one. I'm going to rearrange this one. So let's subtract 3y. X equals -3y minus 7. Done. So now that we know that x equals this, that's not a final answer. I can't just say, oh, well, x, our x coordinate equals this, because it has a variable in it. We need an actual dot on a graph where the x coordinate would be. So instead, we rearranged it. We got what x is as far as an expression. But now we need to borrow this expression and substitute it into the other equation. So which letter, which variable are we substituting it in for? It is for x, because it's what x equals. So we're going to rewrite this equation, and instead of x, I don't want you to see it as x anymore. I want you to see it as -3y minus 7. So let's rewrite this equation. Here we go. 6y plus 5, not x, but it's what x equals, which is -3y minus 7. -3y minus 7 equals 8. You might notice I put it in parentheses. That's because when you're multiplying, a lot of times you'll have to distribute, but it's also so that I remind myself I'm grabbing it by putting it in parentheses and moving it up to substitute in for one of our variables. All right, let's solve this equation because all we have is a y and a y. So if they're the same variable, you can solve it. All right, bring down 6y, distribute the 5. 5 times -3y is -15y. 5 times -7 is -35. All right, these are like terms, so combine those. 6 minus 15 is -9. So -9y minus 35 equals 8. Add 35 to both sides. -9y equals, what is that, 43? This is a bad example of not using your calculator. Always just go ahead and use your calculator to double check. Divide both sides by -9. All right, we've got a lovely uneven number here. However, in a decimal. So we're just going to round it to about negative 4.8. About negative 4.8. All right, so that's our y-coordinate. So our y-coordinate is negative 4.8. What we're missing is our x-coordinate. So we have our y this time. Now we need to plug it into one of the equations, and it doesn't matter which one. We could use this original x plus 3y equals negative 7. We could use this original 6y plus 5x equals 8. Or we could use this rearranged one. I kind of like the rearranged one because all we have to do is multiply and subtract and you've got your answer. So I'm going to rewrite this equation and plug in negative 4.8 in for y because that is our y coordinate. So x equals negative 3, not y, but negative 4.8 about minus 7. Yeah. All right, so let's multiply and subtract, and then you're done. X equals, these two get multiplied, negative 3 times negative 4.8. Negative 3 times negative 4.8 is 14.4. So positive 14.4 minus 7. About 7.4. And it's about because we estimated this number, so that means this one's not going to be exact. So x is about 7.4. All right, let's turn it over to the back. I hope this is making a little bit of sense. We're substituting. Okay, the next part is a word problem. So setting up a word problem and then solving it using substitution. Let's talk about snack bar. A snack bar sells two sizes of snack packs. A large snack is $5 and a small snack pack is $3. And one day the snack bar sold 60 snack packs for a total of $220. How many small? And then really how many large, but it's just asking how many small snack packs did the snack bar sell. All right, so step one is to write the system of equations. Let's let x be the number of large and y be the number of small. So we don't know how many large were sold, that's why it's x. And we don't know how many small were sold, that's why it's y. But we do know how much they cost. So it's 5 times the number of x ones that we sold and 3 times the number of y ones that we sold. So we have 5x, that's the large snack packs, plus we also sold $3 worth times y, which is the small snack packs. And do we know the total cost that we made? $220. $220. All right, and then let's set up our second equation. Here's what I want you to realize. This first equation was all about money. It was $5 plus $3 equals $220. So dollars plus dollars equals dollars. In our next equation, let's just do packs plus packs equals total packs. So do we know how many large snack packs we sold? No. So that's just x. Plus, do we know how many small ones we sold? No. So that's just y. But do we know how many total we sold? We sold 60. So it equals 60. So once again, my two different equations. This one has to do with money. $5 times the number of snack packs plus $3 times the number of snack packs equals $220. The bottom one is just snack packs that are large plus snack packs that are small equals 60 total snack packs. So be sure to be consistent with your with your equations. All right, then what we're going to do is we are going to use the first equation to rearrange and get y by itself. Honestly, I don't care if you get x by itself or y by itself. It's saying it wants us to do it for y, so that's fine. Let's get y by itself. So you would minus x from both sides. Negative x plus 60 because I subtracted x. So negative x plus 60. So now that we have one variable by itself rearranged, we can grab what it tells us that y is, and we can go up here and plug it in for this y. So instead of y, I don't want you guys to see y anymore in this equation because y equals this. Whoops, sorry about that. So we're going to substitute in for y. So I'm going to rewrite the top equation somewhere where I have room. And I'm going to put 5x plus 3, not y, but negative x plus 60, because that's what y is. Negative x plus 60 equals 220. Okay, and now I can solve it because all we have is an x. We don't have both an x and a y variable. So bring down 5x, distribute the 3. 3 times negative x is negative 3x. 3 times 60 is 180. Let's check. Yes. So positive 180 equals 220. All right, combine like terms. 5x minus 3x is 2x. Plus 180 equals 220. Subtract 180 from both sides. 2x equals, that would be 40. Divide both sides by 2. X equals 20. So our x coordinate, now let's think about that. Our x coordinate is 20. We don't know what our y coordinate is yet, but what does x represent? Our x represents the number of large snacks. So we sold 20 large snacks at $5 a piece. If we know that we sold 60 total snack packs, how many does that have to mean that we sold of the small ones? If you're not sure, let's go ahead and choose one of these equations. I'm just going to do this one because that's kind of an easier one. And instead of x, I'm going to use 20 because 20 is our x. That's what x equals. So I'm going to do 20 plus y equals 60. 20 plus y equals 60. And I know you guys could have done this one in your head. I just want to show you how it works. Why it works. Y would be 40. So our y coordinate is 40. Now that we have gotten our x and our y coordinate, let's actually see what the question was they had. They don't care to get the coordinate. They want to know just how many small snack packs did we sell. So again, y was the one that was the number of small. So I want to find my y coordinate, which is 40, and that's my answer. This one was large. This one was small. So therefore, the answer they're looking for is 40 small packs, small snack packs or whatever. Okay, the next one says you try, but since these are kind of hard, if you want to push pause, you can and try on your own. Otherwise, I will do this one with you right now. You paid $22 to rent 6 video games. The store charges $4 for new video games and then just $2 for older video games. How many games did you rent? So let's start with money plus money equals money. We don't know how many new ones we got. I'm going to make my x new. But I know they cost $4 each. So 4x plus, I don't know how many older games. I'm going to make my older games my y. But I know they only cost $2 each. So 2 times, I don't know how many we bought, y. But I know that that money plus money has a total money of $22 it says we paid. So 22. All right, and now let's set up a second equation. You have to always have 2 if you have 2 variables to substitute. When you guys get to Algebra 2, you'll have x, y, and z. You'll have 3 variables, so you'll have to have 3 equations for that to substitute. Okay, we have money plus money equals money. Now let's just do games plus games equals games. I don't know how many new games I got, so that's just x. Plus, I don't know how many old games I got, but I'm going to call that just y. But I do know how many total games I got, 6. So it totals 6. All right, here's my 2 equations. Now that they're done, you can rearrange one of them to get y or x by itself. I'm going to choose one of these. Doesn't matter if you want x or y by itself. I'll get x by itself. So I want a minus y to both sides just to rearrange it, just to get x by itself. Okay, I didn't I didn't get an answer, but I got what x equals. I got a rearranged equation. So I can grab it and plug it into the other equation for x. I hope you guys know now why I'm plugging it in for x. It's because it's what x equals this time. If I had solved it for y, we would have plugged it in right here for y. But I chose, and it doesn't matter, but I chose to get x by itself. So I'm going to take this and grab it and plug it in up here for x, since that's what x equals. So let's go find some space and write this top equation out, but instead of x, I'm going to write negative y plus 6. So 4 times negative y plus 6 plus 2y equals 22. Plus 2y equals 22. All right, let's distribute. 4 times negative y is negative 4y. 4 times 6 is positive 24. Plus 2y equals 22. I'm going to combine like terms. Negative 4y plus 2y is negative 2y. Plus 24 equals 22. Subtract 24 from both sides. I'm going really fast through this, but I know you guys are excellent equation solvers by now. Divide both sides by negative 2. Negative 2 divided by negative 2 is 1. All right, so I know that my y is equal to 1. What was y representing? The older games I rented. So if I rented 1 older game, and I only rented 6 total, what does that mean the other 5 have to be? The new. But if you don't know that, if this is math that's hard for you to figure out in your head, take either one of your equations. I'm going to take this one because it's a lot easier. It doesn't have things being multiplied by it. It's just basic. And now that I know what y is, I'm going to put x plus not y, but 1 equals 6. And I'm going to solve it. I'm going to subtract 1 from both sides. X equals 5. So my coordinates would be, if this was on a graph, 5, 1, because my x coordinate's 5 and my y coordinate's 1, but that's not really what it's asking. It's saying how many new games did I rent? And the new was represented by the x, which is 5. So 5 new games. Okay, this is a great time to take a break and pause and make sure you understand all this. But if you're still with me, we're going to go ahead and talk now about infinitely many or no solutions. So if you're doing equations that have infinitely many or no solutions, this is what it's going to look like. You still have to get x or y by itself. Luckily for us, problem A already has x by itself. Once a variable is by itself, you're going to grab what it equals and substitute it in for that letter. So if x equals this, I'm putting it in for x. So I'm going to rewrite the second equation, but instead of x, I'm going to write negative 2y plus 4. So here we go. 3.5 not x, times negative 2y plus 4 plus 7y equals 14. I'm using this whole second equation. And now I'm only missing y and y, so that means I will be able to get an answer. 3.5 times negative 2y. 3.5 times negative 2 is negative 7. So negative 7y, 3.5 times 4 is 14. So plus 14 plus 7y equals 14. These are like terms. Oh, what happens here? Negative 7y plus positive 7y. If these are opposites, negative 7 plus positive 7 is 0. So those cancel each other out. And if you have a variable that drops out, it canceled out, all you have left is 14 equals 14. Is that true or false? Does 14 equal 14? If what you're left with is a true statement, which it is, that means you will have infinitely many solutions. And what that means is I can plug any number in for x and y, anything you want, and it's always going to work in these equations. There are infinitely many solutions. We already talked about on a graph, infinitely many would be a line that is right on top of the same line, because how many places do those intersect? Everywhere, infinitely. So that's what it looks like on a graph. Here's what it looks like if you just work it out with the numbers, with math. If the variables drop out and you're left with a true statement, the answer is infinitely many solutions. Let's try B. All right, yay. Y is already by itself in the top one again. So I can just grab it and plug it in for Y in the bottom one. So we're going to substitute 3x minus 11 in for y. So here we go. 3x minus 11 minus 3x equals negative 13. Let's solve it because we have x's. All right, right away, I see a 3x minus a 3x. Anything minus itself is 0. They cancel each other out. So what we're left with is negative 11 on the left and negative 13 on the right. Now think about it. Does negative 11 equal negative 13? Absolutely not. It does not equal. That little slash means does not equal. So when this happens, when the variables cancel out and you're left with a false statement, that means there's no possible solution. No solution will ever work for these equations. So what that looks like on a graph, quick review of yesterday. If you have no solution, that means two lines will never intersect. That means they would be parallel. And you might have already realized that because the slope was 3x in this one, and if I got y by itself by adding 3x over here, the slopes in both equations would be 3x. So up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. These are parallel. They would never intersect, so they have no solution. All right, here's two last problems. These are you try, so I really do want you to try these two and then check back. All right, if I were doing these two equations, the first thing I would do is say one of these x's or y's has to be completely by itself. And unfortunately, neither of them are in either equation. So I'm going to have to just take one and just rearrange it. So let me just do the bottom one just because it's down here and so I won't have to move it. I am going to get, it doesn't matter, y by itself. So I'm going to subtract 2.5x. I'm going to have negative 2.5x plus 4. I have to divide both sides by 3. Ooh, I'm just going to leave it. Negative, actually no, let's do the math. What's negative 2.5 divided by 3? It's negative 0.83 repeating. We're going to round it to negative 0.83. X plus, what is 4 divided by 3? 1.3 repeating. So we're going to round it to 1.3. Okay, now that I have y by itself, I'm going to grab this and I'm going to plug it in for y in my other equation. So what we've got is 6, not y anymore, but times negative 0.83x plus 1.3 plus 5x, I'm out of room, I'm so sorry, equals 8. I'll try to be a little bit neater. That is just ends right there. All right, let's distribute. 6 times negative 0.83 is negative 4.98. X, 6 times 1.3 is 7.8. Plus 5x equals 8. Oh, this is hard to see. These two are like terms. Oh, you know what? When I rounded it, these were going to come out to be, this 0.98 would have actually bumped up to 5. So what we have here is negative 5 and positive 5x. What's going to happen is these are going to cancel each other out. So this is negative 5x and positive 5x. So here's what I'm left with. This actually would have rounded up to exactly 8. So I'm left with 8 equals 8. Is that a true statement or a false statement? 8 does equal 8. So this is going to be infinitely many solutions. I'm sorry about all those decimals. If you tried that on your own, I'm proud of you. All right, and then the very last one, thankfully, is already y is by itself. So we can just grab what it says y is and plug it in straight down here for y. So we've got 4x minus 2, not y, but times 2x plus 1 equals 6. Let's solve this. This distributes and is negative 4x. This distributes and is negative 2. Do you see what's going to happen here? This is 4x minus 4x. Those are going to drop out because 4x minus 4x is 0, and it's going to leave us with negative 2 equals 6. Does negative 2 equal 6? No, it does not. So that means this would be an example of a no solution.